students. Today's agenda is to solve simple elimination, systems of equations with simple elimination. And the homework will be 5.6. And today students will be able to find the solution of systems of equations by elimination. And I want you to write these steps first. Because we're going to be needing them throughout. Maybe you can put them in a little flashcard so you can have them with you in front. And so it says the first step is to check for opposite coefficients, and you will understand once we get to the examples what that means. We're going to add the equations once we have opposite coefficients, and then we're going to solve for the remaining variable because we're going to be eliminating one of them, and finally get one of the equations and substitute the solution that we got in here to find the solution or the answer for the other variable. Again, take note of this and it will make more sense when we get to it. Okay, so I'm going to have this in front of us so we can know. So in the previous lesson, remember that we learned to find the solutions of a system of equations by graphing. And what it meant is that we would be able to find if two lines cross or meet at one point, which is one solution. They don't meet, meaning they are parallel lines, that means no solution. Or if they have infinite solution, meaning that they overlap, that every single point is a solution for both of the equations. Okay, so instead of graphing, what you're going to be doing today is finding that answer, that coordinate, but algebraically. Okay. Okay, so let's start with the first exercise. And so we have x plus y equals 5 and x minus y equals 1. And so it says to check for opposite coefficients. So we look at one and we, so maybe I should go over what are opposite coefficients first. And opposites will be 8 and negative 8. And when I add 8 and negative 8, they cancel and that equals to 0. If we have negative 1, what would be the opposite of negative 1? 1, because when I add negative 1 plus 1, that's equals to 0. What about if I have 5? Well, the opposite will be negative 5. So again, when we add these two to their opposites, which is the inverse property of addition, the answer will be equals to 0. Okay, so basically they cancel each other. Okay, so let me put a little note in here. Let me see if I can fit it. Maybe to eliminate one of the variables, we need to have opposite coefficients. We need opposite coefficients. And today, for today's assignment, they are set up so that you will have opposite coefficients, but in the future you will have to figure out how to make those opposite coefficients. Okay, so let's look in here. We look at x and the coefficients is 1 and 1. They're not opposite because both are positive. But then we look at the coefficients of y and we have positive 1 and negative 1. They are opposite of each other. So that means that these are ready to cancel. So whenever you do have a pair or opposite coefficients for one of the variables, that means that you're ready to add the two equations. And so we start x plus x, 2x. Y minus y, 0. That's why they cancel. Equals 5 plus 1, 6. See, so you were able to eliminate one of the variables, right? Because we had opposite coefficients. The next step is to solve for the remaining variable. So now that we eliminated one of the variables, we have a remaining variable. So I can start solving by canceling. And since I'm multiplying, the opposite is divide. And so x is equals to 3. Now remember that we need to find where they meet, but for the order pair, meaning the coordinate, you need x and y. So we already have x in here, right? For the solution, we already have x, which is 3. But what is the value of y? And so the next step to be able to find y is to get one of the equations and substitute the solution. Now, this is one of what I've noticed is that some students want to get both of the equations and start canceling like we did for y, but that's not how we do it. We choose one of the two equations, and it doesn't matter which one. You can choose the first one or the second one. I'm going to choose the first one in this case. You will get the same answer, but you get only one. Forget about the rest. Okay, so you're gonna get x plus y equals 5. So x plus y equals 5. But then you look at the value of x that you found before, and you're going to replace that in here. And the rest will stay the same. Now you're just substituting that value, but the rest stays the same. And you start solving. So take away 3. And so my y is equals to 2. Okay, so these two lines, if I were to graph them, they would meet at point 3, 2. x3 and y2. Okay, so this is my solution, basically. Okay, let's do another one. And now we have 3x plus 2y equals 8. And negative 3x plus y equals negative 5. Again, we check for opposite coefficients. So I check the coefficients of x, and I have a positive 3 and a negative 3. So yes, I can immediately see that that's ready to be canceled. So I'm ready to add the equations. And when I add, I have 3x minus 3x is canceled. 2y plus y is 3y equals, and 8 plus negative 5 is positive 3. Then I solve for the remaining variable, the one that wasn't canceled, and I divide by 3. And so y is equals to 1. Then the confusing part, right? I get one of the equations, only one of them, get one of the equations and substitute my answer in that one equation. So again, I'm gonna get the first one. 3 times x, because what I need to be careful, don't always replace the same variable. You have to look at what variable you have the solution for. So in this case, you have y, you're going to replace your y. Plus 2 times y, which is 1, equals 8. Notice how I have everything the same except replace y in there. And so I'm going to start solving. I forget about this one, okay? So it's going to be 3x plus 2 times 1 is 2 equals 8. I cancel 2 by subtracting, and so 3x is equals to 6. Divide both sides by 3, and so x is equals to 2. Okay, so my solution for these two equations is x is 2. You have to be careful again. X is always first and y is second. So they will meet at coordinate 2, 1. Okay, another one. I have negative x plus y equals 0. X plus y is equals to 0. And so what are the two coefficients that are opposite of each other? Well, we can see that x has a positive and the other one is a negative, so that means that they can cancel each other. So I add them, and negative x, I owe a box and I have a box, they cancel. Y plus y is 2y is equals to 0 plus 0 is 0, and then I divide by 2, so y is equals to, anytime we have 0 divided by any number, the answer will be 0. The next step, I already solved for the remaining variable, and I get one of the equations. In this case, I'm going to work with the second one. Again, it doesn't matter which one you choose because you will get the same answer. I substitute the y, so the y, its value is 0. Notice how I take away the y and put the 0 in its place. And then x plus 0 is x, and you just bring down your 0. So this set of equations, this system of equations will meet at the origin at 0, 0. Okay. Please do write your answer always as an order pair, as a coordinate, because that's what I'm going to be looking for. Okay, so if I have 3x minus 2y is equals to 12, and then I have negative 3x minus 8y is equals to negative 72. Again, the x has opposite, so that's the one that is going to be eliminated. And so I'm ready to add them because I have opposite equations. This cancels, and I get negative 10. Remember that when we have negatives, that both are negatives, it's addition of negatives. And so it's going to be negative 10y is equals to negative, when we have different signs, we subtract and leave the sign of the bigger one. So 72 minus 12 is 60, and we leave the negative because the 72 is bigger. We divide both sides by negative 10, and so y is equals to positive 6. Okay, I already have my y. Now I only need to find my x. And so for the x, I'm going to get one of the equations. And I notice that I'm keep insisting on this because this is the part where some people either forget it or they get confused. Get only one of the equations, but substitute the solution of y. Okay? So it's going to be 3x minus 2 times the value of y. And notice how in the previous one I put 2y and then substitute in the second step. Either way, you can just do it shortcut and go directly to substituting. Equals 12. 3x, negative 2 times 6 is negative 12. Equals 12. I cancel by adding 12 to both sides. And so 3x is equals to 24. I divide both sides by 3. And so x is equals to 8. So I'm going to put my 8 in here. So that will be my solution for this set of equations. That's where they're going to meet. And later on, we're going to relate this to the coin problems and the table length, etc. So it would say there are one measures 8 inches, 8 feet, and the other one is 6 feet, or I have 8 quarters and 6 dimes, etc., etc. So that's what it will come down to. Okay, but I hope you can now work on 5.6. Thank you.